Hi everyone, I am Pooja from SVC Computer Science Department. Today my topic is about system software and compiler. So these are the contents of our topic, that is introduction to SIC XC, registers, addressing modes and flag bits, and problems. So introduction. SIC-XC is an extension version of SIC machine architecture. The maximum memory available on it is 1 megabyte, that is 2 to the power 20 bytes. It has an additional B, S, T and F registers in addition to the registers of SIC, and it has 4 instruction formats, that is format 1 which consists of 1 byte, format 2 which consists of 2 byte, format 3 3 byte, format 4 4 byte, and registers. This we are going to use in our problems, that is there are 9 registers, that is accumulator, index register, linkage register, base register, and two general working registers, floating point accumulator, program counter, and status word. Here are their mnemonics and their number. Their value is given. So addressing modes and flag bits. So base relative as n is equal to 1, I is equal to 1, b is equal to 1, p is equal to 0. And the equation for its displacement is target address minus base, where displacement is from 0 to 4095 bits. Same as PC relative, direct, immediate, indirect indexing. In extended, E is equal to 0 for format 3, E is equal to 1 for format 4. So this is object program format. It consists of header, text and end. So this is the problem. Here we have label field, this is opcode field, and this is operand field. Here we are going to write location counter, and here we have to find object code. So we'll find the format is already given. If it contains a register, then it is format 2. If it doesn't have a register, it is format 3. And the starting address of the location counter is 105D. We'll write it 105D. We'll add 2 to it. The calculator must be in hexadecimal mode. So after adding 2, we'll get 105F. And again we'll get 106 by adding 3, and 106 5 and 106 8 106 B and 106 E. Now we'll add 2 for 106 E. We'll get 107 0, and we'll add 3 107 3, and here 107 6. As this is byte, we'll take it as 1 and we'll add 1 0, 7 and 7. So this reserve byte is of 400. It has 400 as operand. We'll convert it to hexadecimal and we'll get as 190. We'll add it. So hexadecimal value of 400 is 190. We'll add it to 1077. We'll get 1207. Here we'll add 2 for this. We'll get 1, 2, 0 and 9. So this is the location counter. So we have to find object code for this now. So X is a register. X is a register which is of format 2. So we have drawn this table for format 2. This is object code which has 8 bytes, and this are registers each of 4 bytes. So the value of clear is B4. The value of B in binary is 1011 and 4 is 0100. We have written this, and the value of X, the register X is 1, which is given in the question, so it is 1, and there is no another register, so we'll take it as 0. And for format 3 we'll follow this, and the object code as 6 bytes and each flag as 1 byte, and the displacement is of 12 bytes. So the value of LDT is given as 74. The value of 7 is 0111, and the value of 4 is 00, because it should contain only 6 bytes. So we'll take the starting 2 bytes of 4, and as it is direct mode, this one is N, this is I, this is X, and this is B, this one is P, and this is E. So as it is direct mode, N is equal to 1, I is equal to 1, and it doesn't contain any register, so X is equal to 0, and B and P value we'll find out later. As it is format 3, it is 0, and to find displacement we have to take the target address of length, that is 1, 2, 0, 7, and the program counter of length, that is 1062. If you subtract this, you are going to get 1A5. And if you convert this to decimal, that is 1A5 to decimal, you are going to get 421, which lies between the value of uh, minus 2048 and 2047. So B is taken as 1, sorry, B is taken as 0 and P is taken as 1. We are going to do the same thing for every format. So we'll find the object code in the same way for every location counter. And now we have this where the buffer comma x, it has a register, so it is same, that is 6 for object code, and this is n, this one is I, this is x, this is b, p, and e. Here x is equal to 1. Here x is equal to 1, as in operand they have given buffer comma x, so x is equal to 1. The same thing applies for every object code. And so we have found out the object code for every location counter, and we are not going to write object code for this end and reserve bytes, and bytes object code is 05, which is given in question itself. And now we have to find object program, that is we'll take h, which is header, and we'll write the name of the program, that is WRREC. WRREC. And the of starting address of the program, that is which should have 6 byte only, that is 00105D. And the length of the program, is we have to calculate it as the last location counter, the value of last location counter, that is 1209, and the starting location counter, that is 105D. 1209 minus 105D. If you subtract it, you'll get 1AC, which is written here, and even that should be in 6 bytes, so 0001AC. And the text field, that is T, and starting address, and we'll leave some space over here and write all the object code, and total there are 52 bytes in the object code, and we'll make it half, we'll get it as 26, and after converting it to hexadecimal we'll get 1A, which is written over here. And finally the end, which has again the starting address of the program. Thank you.